Good evening, children.
Good evening.
How are you?
How are you, ma'am?
I'm good. How are you, beta?
I'm fine, ma'am.
Okay. Chalo, let's begin. So you have some revision test today, no? What do you have? Which chapter you have for revision test today? Hello? Hello? Can you hear me?
Yes,
Yes,
ma'am.
ma'am. Yes, ma'am.
So in the revision test, which chapter you have for the revision test?
Just a minute, ma'am.
Those who have opted for the revision test.
Ma'am, 1 minute. Ma'am, playing with numbers.
Playing with numbers. Okay. So let's revise playing with numbers.
Yes, ma'am.
In the last class, we had done the whole numbers, right?
Yes, ma'am. Whole numbers.
Okay. Neha, Nishika, please turn on the videos. So today we are revising playing with numbers. Let's move to the screen. Okay. This is playing with numbers. See, in the beginning, you had all small questions. See, first of all, in this, you should know all the prime numbers between 1 to 100, right? Everyone knows all prime numbers between 1 to 100?
Yes, ma'am.
Okay, if you don't know, you have to learn all the prime numbers between 1 to 100, right?
Okay.
Okay. So, write all the factors of the following numbers. Now, you have to write the factors in this. See here. Now, let's take any number. Say 24 I have taken. How do you write the factors of 24? Can you make the factors of 24? Yes, Neha, tell me the factors of 24.
Ma'am, 1,
1,
2,
2,
ma'am, 3, 4,
3, 4.
6,
Yes,
8,
yes.
12, and 24.
12 and 24. Very good. Okay, so this is how you find the factors of 24, right? So if I tell you, Nishika will tell me factors of 36. Nishika,
Yes, ma'am. Ma'am, 1,
okay,
2,
okay,
ma'am, 3,
okay,
4,
okay.
6,
Hmm. Yes,
ma'am, 12,
12, and before that you have 9 also.
sorry, ma'am, 12,
Yes,
and then 36, ma'am.
36, 12, and then you have 18, you have 36. Any more factors? Are these all done?
No,
Yes?
no, I'm not.
What is missing? Is there anything missing? Any factor is missing?
No, ma'am.
Okay. So you all know how to make the factors now? Okay. Trilokya, tell me the factors of 23.
Yes, ma'am. Ma'am, 23 is a prime number.
So what are the factors?
Ma'am, 1 and 23.
1 and 23. Okay, good. Okay. So list 5 multiples of these numbers. See, now you have number of factors are finite. Now suppose when I said factors of 24, so you had some limited numbers, no? Right? You had some limited numbers. When we read the factors of 36, we had some limited numbers which are factors of 36. But when I say about multiples, multiples are Many. Okay, there are infinite multiples. As many you multiply with 5. If I have to find the factor multiples of 5. So 5 ones are is a multiple. 5 twos are 10. 10 is a multiple. 15 is a multiple. 20, 25, and so on. I keep on multiplying 5 into 11, 5 into 12, 5 into 13. Okay. So all those numbers that I get by multiplying it further and further, they are all multiples of the number. Are you understanding? Now suppose multiples of 5 are 5, 10, 15, 20, like this, so on. So any number ending with 5 at the units place, 5 and 0 is a multiple of 5, right? So there are infinite numbers, infinite multiples, but the number of factors are limited, they are finite. Okay. Okay, let's see further. Find all the multiples of 9 up to 100. So can you find the multiples of 9 up to 100? Yes.
Yes.
Okay, which is the highest multiple which closer to 100? Multiple of
99.
99. Okay, now let's see. These are some facts about the prime numbers. Let's see. The numbers 13 and 31 are prime numbers. Both these numbers have same digits 1 and 3. Okay, so these numbers are written in reverse order 113 and 31. Find such pairs of prime numbers up to 100. So you have to find some more prime numbers with the made with two digits. Okay, like suppose 17 and 71. So 17 is also prime, 71 is also prime, right? 37 and 73, 79 and 97, right? Are you understanding? So we are only revising now. So we'll soon go to the HCF and LCM part also. But before that, you should know the facts about prime numbers. Okay, write the greatest prime number between 1 and 10. Which is the greatest prime number between 1 and 10? Simple.
Ma'am, 7.
7. Okay, so express the following as the sum of two odd numbers. So you have to express these numbers which are given here in terms of two odd numbers, two odd primes. It's saying two odd primes. Now suppose this is 44. So there are different ways of writing. It's not only that 37 and 7 will make 44. It can be some other combination also. Okay, but it should be odd number, prime number. Okay, all prime numbers are odd only except 2.
Ma'am, 41 plus 3.
41 plus 3. Okay, so you can make different combinations also, right? 37 plus 7, 36 you can make by 31 plus 5. If you have to make 24, can you find any more combinations of 24? Neha? Yes, Neha?
Yes, ma'am.
Express 24 as the sum of odd primes. 11 and 13 is already written
Yes,
here.
ma'am.
And 11 and 13 is one combination. Think of something more. Others also please think. Can you give me some more, some different combination for
Ma'am, 19 and 5.
19 and 5? Okay, yes, good. Okay, tell me for 18, Shreyansh. 13 and 5 is already written. Tell me something different. 18.
18, ma'am. Okay. 18. Ma'am, 7, no. Ma'am, 13 plus 5.
13 plus 5, yes, 13 plus 5 is correct. Think of something more also, some more different if you can think of. Yes, anyone else also? You can also give your ideas. Trilokya, Nishika,
11 plus 7.
11 plus 7, okay. Yes, good. Okay, 11 and 7. Okay. Give 3 pairs of prime numbers whose difference is 2. So these the prime numbers with the difference of 2 are called twin primes. Okay. 2 prime numbers whose difference is 2 are called twin prime numbers. Okay. So same way you have another set of prime numbers, twin primes and co-primes also. Right? You must have heard the name co-primes also. So twin primes are those numbers which are in a difference of 2, like suppose 3 and 5. These are 2 prime numbers. The difference between them is 2. Right? 11 and 13. The difference between them is 2. So we call them as twin primes, right? So 41 and 43. So for quick answering, you should know these things. Okay? Right? These are very common and basic facts about prime numbers. 71, 73, 17, 19. And all these things will quickly come to your mind only when you know the prime numbers. You should know all prime numbers between 1 to 100. Right? Will you learn that today? And even if you know beforehand, you should revise it. Okay? Then only you can give the quick answers, prompt answers. Okay? Okay, now which of the following numbers are prime? Okay, from here you have to find the prime numbers 23, 37, right? Okay, let's move further. Express each of the following numbers as the sum of 3 odd primes. Now it's saying about 3 odd primes. In the above question, we had 2 odd primes. Now it's 3. Now 21 to be expressed as 3 prime numbers, right? So combination for 21 is 11, 7, 3. So like this, you can make some different combinations. Okay. 31 can be made by 11, 17, 3. Like this. 40, 53 you can write as 41, 7, 5. 61 can be written as 41, 17, 3. Okay. If you want to note down, you can please note down. Right? Otherwise, we had already done also when we did the chapter. Nishika, are you understanding?
Yes, ma'am.
Hello? You were not there with the when we had done the chapter. Okay, but are you, if you're not understanding, you can ask me. Okay, stop me in between. You can ask.
Okay.
Okay, so okay, so fill in the blanks now. A number which has only 2 factors is called prime numbers. A number which has more than 2 factors is called, what do you call it? Say it loudly. Composite numbers. Everyone has to say 1 is neither dash nor dash. So 1 is a special number, no? It is neither prime nor composite. Now tell me the smallest prime number is 2. And it is also the even prime number, the smallest even prime number. This is the only even prime number. Okay. And the smallest composite number is number 4, no? Because 2 and 3 are prime numbers. So composite numbers start from 4 because 1 is neither prime nor composite. So neither 1 is composite nor 2 is composite, 2 is prime, 3 is prime. So 4 is the composite number, smallest one. Then we have the divisibility rules. Okay. So first is the divisibility by 2. So divisibility by 2 is that all the even numbers are divisible by 2. So whichever number at its units place ends with 0, 2, 4, 6, 8 are all even numbers, right? And other than those are all odd numbers. Even numbers, and they are all divisible by 2 also. Okay. Okay, then is the divisibility by 3. So to check the divisibility by 3, we add up all the numbers. Now suppose if you have this example 7, 2, 2, 1. So we just add all the digits and see whether they are all divisible by 3. That is, that if the number comes in the table of 3, then we say that the number is divisible by 3. Okay. Like 7 plus 2 is 9, 9 plus 2, 11, then 12. So 12 is divisible by 3, 12 comes in the table of 3. So yes, so we say that this number is divisible by 3. That is 7221 is divisible by 3. Right? Next is divisibility by 6. Divisibility by 6 is if the number is divisible by 2 and 3. So factors of 6 are 2 and 3. If the numbers are both divisible by 2 and 3 both, we say that the number is divisible by 6. Right? So if you can take any example, it is here. Okay, we'll take the example afterwards. Now divisibility by 4. If you have any bigger number and you say like number is here given 286, right here. So we check whether the last two numbers, if they are divisible by 4, we say that the whole of the number is divisible by 4. Whatever big number it is, 1, 4, 5, 6, 7, 9, 4, like this. Whatever big number it is, if the last two digits are divisible by 4, we say that the whole of the number is divisible by 4. Okay? Yes? Okay, then next is the divisibility by 8. So same like divisibility by 4. In 8, we say that the big number is divisible by 8 only if the last three digits, if they are divisible by 8, then the whole of the digit is divisible by 8. Okay? In 8, we check the last three digits. In 4, we check the last two digits. Then divisibility by 9. Divisibility by 9 says that like it's same as the divisibility by 3. Okay, when we suppose this is the number given, we add all the digits and whatever sum we get, we check whether it's divisible by 9 or not. Does it come in the table of 9? Is it, if the number is divisible, sum of the digits is divisible by 9, then the whole of the number is divisible by 9. Okay. Next comes the divisibility by 11. So divisibility by 11 says that the difference between the sum of the digits at the odd places and at the even places, if their difference is 0 or 11, then the number is divisible by 11. Right? How can we say that? Now suppose you have some number 7, 0, 3, 8, 4, 5. If you have this number. So digits at the odd place. This is one number, then 2. So digits at the odd places. Okay. And digits at the even places. If you take the difference between these, sum of these, like suppose 0 plus 8 plus 5. Okay. So these are the digits at the odd places. This is 13. If you take the sum of these digits at the even places, 7 plus 3 plus 4. So this is 14. Right? So when you take the difference between these, this is 1. Okay. So it's saying that suppose if the difference between them is 0 or 11, okay, then we say that this number is divisible by 11. But in this case, the difference is 1. So this is not divisible by 11. Right? Are you understanding? Okay. Okay, so based on your divisibility rules, you have this exercise. Okay, so we are not going much deep into it. Okay, now find the common factors of the numbers are given. So to find the common factors means you have three numbers given, 75, 60 and 210. Okay, so if you make the factors of 75, 60, 210, so whatever factors you see in common, this is 3, this is 3, this is 3. The factor that you see common in every factor of every number, so those factors are the common factors. Okay, so we see 1 is common, 1 is of course always common in every factor, then 3, then 5, then 15. So these are some common factors in these three numbers, right? So those are common factors. And highest of the factors. Now, if in this list of common factors, if you see the highest factor is 15, is it? Yes. So the highest number in this is called the highest common factor. Okay. Right? Okay. Okay. Now same way. So this was about the factors. Okay. Now here comes the word co-prime. Now co-prime numbers. See, I told you twin primes and co-primes are two set of numbers. Twin primes are those numbers which have a difference of 2, right? The difference between them is 2. Co-primes are those numbers which have only one as a common factor. Okay? Common factor, which has only one as a common factor. Suppose I take the example 15 and 37. So 15 and 37, there is no common factor between these two numbers. Only one is the common factor, right? So these type of numbers are all co-prime numbers. So every consecutive number you can say is a co-prime, 3 and 4, right?
One is like to prove that these are co-prime. One number is prime.
Which one? Which number?
Like we should if we have to tell like these two are co-prime, then one number should be definitely prime only, ma'am, or
So that means they have only one common factor, one as a common factor. Suppose if we have to write the factors of 15. So factors of 15 are 1, 3, 5, right?
yes, ma'am.
Yes. And factors of 37, 37 is a prime number. So factors are only 1 and 37. So 1 is such a number which is common between them.
Okay.
So any such number which has only one as a common factor between them. Okay, that is called co-prime. So you can say the consecutive numbers 3, 4, 7, 8, 11, 12. Is there any common factor between 11 and 12 other than 1? Other than 1? No. So if you take any consecutive number 37, 38, 42, 43, okay? So they are co-prime numbers, okay? Next is prime factorization. Okay. Now for prime factorization, I give you a number. You will find the prime factors of it, okay? Write the greatest 4-digit number and express it in terms of its prime factors. How do you make the prime factors? Like this, you make a grid here. Suppose I have a number, say 36. I'll make the factors of this, right? So all prime factors which I will take, that will give me the set of prime factors. So that this is 2, 18, 2, 9, 3, 3, 3, 1. Okay, like this. So find the greatest 4-digit number and write its prime factors. Okay, do it in your notebook.
Ma'am, I don't understand the question.
Now see, Nishika, I'm saying the greatest 4-digit number, you have to write its prime factors. You know, what are prime factors? Prime factors are, I'm writing factors. Suppose I'm writing the factors of 36. You told me all the factors of 36, no? Yes?
Yes.
So all that you told me, tell me once again, what are the prime factors? What are the factors?
1,
Hmm.
2,
Hmm.
3,
Hmm. Yes.
6,
Hmm.
ma'am, 9,
9.
12,
Hmm.
18,
Hmm.
36.
And 36. So these are all the factors you told me. But when we are talking about prime factors, we take only those numbers which are primes. 2 is a prime number, 2 is a prime number, 3 is a prime, 3 is a prime. Right?
Yes, ma'am.
Are you understanding? So here there is no 4, there is no 9, there is no 6, there is no 12, nor 18. Okay, but when we multiply all these, we'll definitely get 2 into 2 will 4. We will definitely get. But actually, what factors we are getting here? These are all prime numbers. Okay, I hope you're understanding.
Yes.
So, which number you think as the greatest 4-digit number? Which is the greatest 4-digit number? Tell me the greatest 4-digit number, Nishita. Yes, Nishita. Hello.
Yes, ma'am.
Nishita, yes, tell me which is the greatest 4-digit number.
Ma'am, 9,999.
9,999. So find the factors of this. And the factors, there are two ways of finding factors. Okay, one is this, another one is like this also with the factor tree method. Okay, so we are doing with this. So what do you see here? Can I divide this by, okay, I'll take the prime number here directly. 3, 3, 3, 3, right? Again 3, 1, 1, 1. Okay. Now next number, which one can be there? This, if I can take 11, 11 ones is 11. Then I drop down one more, I get 0, then 1. So that's 101. Now 101 is a prime number. So that means it has no factor, right?
Yes,
So my
ma'am.
all prime factors for this are 3 into 3 into 11 into 101. Yes?
Yes, ma'am.
Understood this?
Yes, ma'am.
Okay, now do the next one. Do yourself. Write the smallest 5-digit number. Now you first write the smallest 5-digit number and write its prime factors. As we did this, no? Same way, find the prime factors. Anyone has a doubt here? Please ask. Done? Yes?
Ma'am, which one, no? The-
Done?
Which one, ma'am? Is it done?
No, I was saying the previous question is that the smallest, the smallest 5-digit number, you have to find the factors of this, okay? Okay, now see the HCF and the LCM part. HCF is the highest common factor. When you take the factors of this, the highest of the factor is called highest common factor. Suppose if I take 18 and 48. So what do? I take the prime factor of this 2, this will go with 9, this is 24. Right now I can take with 3, 3 3s are 3 8s are, right? Now can I find any more prime common factor in this? Is there any more common factor? See, 8 can have different factors, 3 can have different factors, but is there any factor which is common between both 8 and 3? No. Okay. So there is no more common factor here. So the only common factor was 2 and 3. So when I multiply 2 and 3, I get 6. Okay. Are you understanding? So 6 is the highest common factor of these two numbers. Right? Understanding, Nishika?
Yes, ma'am.
Okay, so similarly, you can take up any question at 2763. Any question you can take up here, okay? So the common factor which is there between the three numbers, that will give you the highest common factor. When you multiply only the common factors. So common factors we are writing this side, right? Okay, now if I tell you to find the LCM, okay, the least common multiple. Okay, here you have the statements. Okay, anyway, with the same example only I'll show you to find the LCM. Now we did two nines and two 24, then we had 3, 3 and 8. Now if I say it's HCF, you said it was 6, right? We found the HCF is 6. So HCF is only the product of the common factors. Uh, but when we are finding the LCM means the least common multiples. See, common multiples are infinite, right? But the least number, the smallest of all the common multiples is called the least common multiple, right? So when I'm finding the least common multiple, so I will take the HCF also and I will multiply these also, right? I will multiply these also. So my LCM will be 2 into 3 into 3 into 8, right? Are you understanding? So 2 into 3 is 6 and 6 into, this is 8, 3 is 24. So 24 into 6 is how much? 12, 13, 14. This is 144, right?
Yes, ma'am.
Okay, are you understanding? For LCM, we will take those numbers also which are left after taking the common factors. We will multiply all these numbers here, right? I have told you keep this L shape in the mind, this like this and like this. So all those numbers which come here at the end, you will multiply them. L for LCM. Just a memory tip, okay? Right?
Yes, ma'am.
Multiples are infinite. So the least of them is called least common multiple. Okay. Now there are some statement sums. Let's see some few sums. Renu purchases 2 bags. Now understand there are in statement sums you need to first find out what will you find out here, HCF or LCM, by understanding the statement. Okay. So Renu purchases 2 bags of fertilizers of weights 75 kg and 69 kg. Find the maximum value of the weight which can measure the weight of the fertilizer exact number of times. So what you have to do, you have to find the maximum value of the weight which can measure the weight of the fertilizer exact number of times. So maximum value of the weight you have to find out. What will you do in this question? Who will tell me? We have done this question earlier. Yes. HCF, absolutely. Okay. You should be prompt in your answer. Are you understanding? Trilokya, Nishika, Neha.
Yes, ma'am.
Okay. So what will you do? 75 and 69 are the weights of the two different bags. You will find the HCF of these two, 79 and 65. So quickly find the HCF. Find the HCF. Okay, Nishika will tell me. Nishika, what is the HCF of 75 and 69? Yes, Nishika.
None is left. No.
What is it? What is your answer? What is the HCF?
I'm doing it. No. None three.
3. So 3 is the HCF. That means with the container of 3 kg, you can measure these two weights exactly, right?
Yes, ma'am.
Okay. With the container of 3 kg, you can measure them exactly. Okay, let's take question number 2. Trilokya, read question number 2.
Yes, ma'am. Three boys step off together from the same spot. Their steps measure 63 centimeters, 70 centimeters, and 77 centimeters respectively. What is the minimum distance each should cover so that all can cover the distance in complete steps?
So now see, 3 boys are stepping together. Okay, this is boy A, boy B, boy C. Okay, they are stepping together from the same spot. This is their start points. Okay, then like in your school, in your sports day, you must have started with the races. You all start from the same point. Okay, so they are starting. So their steps measure. So one person step is measuring 63 centimeters. Okay, that means when you take one step, it is of 63 centimeters. Second boy is 70 centimeters. Third boy is 77 centimeters. Their steps. Okay. Now, what is the minimum distance each should cover so that all can cover the distance in complete steps? Now they have to come at this finish point. That means they should complete their distance in complete number of steps. Yes? Did you understand the question?
Yes, ma'am.
What is the minimum distance each should cover so that all can cover the distance in complete sets? So what will you do in this question? What will you do?
Find the LCM.
Yes, we will find the LCM. Okay, so 63, 70, 77, right? You will find the LCM of this. So same way, we have next question also. The class time is over. So we'll just discuss this question. The trust, you can find the LCM later on. Okay, whatever LCM you get. Just please pay attention here. Just understand this question. Traffic lights at 3 different road crossings change after 48 seconds, 108 seconds, 72 seconds, 108 seconds respectively. If they change simultaneously at 7 a.m., at what time will they change simultaneously again? Now what you have to do, that means the 3 traffic lights have different time spans, right? So they might change many times. They will change, they will come together many times, okay, in a day. So you have to find, what will you find after how many times will they change again? So once they started at one point, after 48 seconds, suppose at instant they together change the traffic lights changed. Okay, so when will that incident come again? So what will you do in this case? They will change many times like this, no? But you have to find the least one. At the very first time when they will change.
LCM.
You will take the LCM of this 48, 72 and 108. Right?
Yes,
Okay. Okay, so please practice these questions, okay? Right, children?
yes, ma'am.
Yes, ma'am.
Okay, beta. Thank you. Thanks for joining. Please
Thank
do
you,
all
ma'am.
the sums. Just as a part of revision, we have taken some few sums and we have discussed. But for your practice, you must do each and every sum because not only the revision test, but also your school examination. For your school examination, you should do them nicely. Okay? So do each and every sum and every example of the book. Okay, beta. Thank you. Bye to all.
Bye, ma'am. Have a nice day.
Thank you, ma'am. Have a
Beta.
nice day.
Okay, bye-bye.